Traffic lights, also known as traffic signals, traffic lamps, signal lights, stoplights and robots, and also known technically as traffic control signals, are signaling devices positioned at road intersections, pedestrian crossings and other locations to control competing flows of the traffic. The first manually operated gaslit traffic light was installed in 1868 in London, albeit it was short-lived due to explosion. The first safe, automatic electric traffic lights were installed in the United States starting in the late 1890s. Traffic lights alternate the right-of-way accorded to road users by displaying lights of a standard color following a universal color code. In the typical sequence of color phases, the green light allows traffic to proceed in the direction denoted, if it is safe to do so. The yellow light provides warning that the signal will be changing from green to red. Actions required by drivers varies, with some jurisdictions requiring drivers to stop if it is safe to do so, and others allowing drivers to go through the intersection if safe to do so. A flashing yellow indication is a warning signal, the red signal prohibits any traffic from proceeding, a flashing red indication is treated as a stop sign. Traffic signals will go into a flashing mode if the controller detects a problem, such as a program that tries to display green lights to conflicting traffic. The signal may display flashing yellow to the main road and flashing red to the side road, or flashing red in all directions. Flashing operation can also be used during times of day when traffic is light, such as late at night. History. On December 10, 1868, the first non-electric, gas-lit, traffic lights were installed outside the British Houses of Parliament in London to control the traffic in Bridge Street, Great George Street and Parliament Street. They were promoted by the railway engineer J. P. Knight and constructed by the railway signal engineers of Saxby and Farmer. The design combined 3 semaphore arms with red and green gas lamps for nighttime use, on a pillar, operated by a police constable. The gas lantern was manually turned by a traffic police officer, with a lever at its base so that the appropriate light faced traffic. Although it was said to be successful at controlling traffic, its operational life was brief. It exploded on 2 January 1869, as a result of a leak in one of the gas lines underneath the pavement, injuring or killing the policeman who was operating it. With doubts about our safety, the concept was abandoned until electric signals became available. The first electric traffic light was developed in 1912 by Lester Wire, an American policeman of Salt Lake City, Utah, who also used red-green lights. On August 5, 1914, the American Traffic Signal Company installed a traffic signal system on the corner of East 105th Street and Euclid Avenue in Cleveland, Ohio. It had 2 colors, red and green, and a buzzer, based on the design of James Hodge, to provide a warning for color changes. The design by James Hodge allowed police and fire stations to control the signals in case of emergency. The first 4-way, 3-color traffic light was created by police officer William Potts in Detroit, Michigan in 1920. Asheville, Ohio claims to be the home of the oldest working traffic light in the United States, used at an intersection of public roads from 1932 to 1982 when it was moved to a local museum. The first interconnected traffic signal system was installed in Salt Lake City in 1917, with 6 connected intersections controlled simultaneously from a manual switch. Automatic control of interconnected traffic lights was introduced March 1922 in Houston, Texas. The first traffic lights in England were deployed in Piccadilly Circus in 1926. Toronto, Ontario was the first city to computerize its entire traffic signal system, which it accomplished in 1963. Countdown timers on traffic lights were introduced in the 1990s. Timers are useful for pedestrians, to plan if there is enough time to attempt to cross the intersection before the end of the walk phase, and for drivers, to know amount of time before the light turns green. In the United States, timers for vehicle traffic are prohibited, and pedestrian timers are now required on new or upgraded signals on wider roadways. Types. Single aspects. The simplest traffic light comprises either a single or a pair of colored aspects that warns any user of the shared right-of-way of a possible conflict or danger. Flashing red, treated as a stop sign. also can signal the road is closed. Flashing yellow, caution, crossing or road hazard ahead. Flashing green, varies among jurisdiction. Can give permission to go straight as well as make a left turn in front of opposing traffic, can indicate the end of a green cycle before the light changes to a solid yellow, or indicates the intersection is a pedestrian crosswalk. Dual aspects, these are often seen at railway crossings and at intersections of streets. They flash yellow when a cross traffic is not expected, and turn red to stop traffic when a cross traffic occurs. They are also used on ramp metering, where motorists enter a freeway in heavy traffic. Only one driver per lane goes per green. 3 or more aspects, the standard is the red light above the green, with yellow between. When sideways, the arrangement depends on the rule of the road. In right lane countries, the green light is on the right, and in left lane countries, the left. Other signals are sometimes added for more control, such as for public transportation and permissive turns. In some jurisdictions, for a brief time, they also turn red in all directions, to clear any traffic in the intersection. The delay can depend on traffic, road conditions, the kind of intersection, and legal requirements. Older signals sometimes have no all-red phase, and the light turns green for cross-traffic the instant the other light turns red. The 3-aspect standard is also used at locks on the upper Mississippi River. Red means that another vessel is passing through. Yellow means that the lock chamber is being emptied or filled to match the level of the approaching vessel. After the gate opens, green means that the vessel may enter. In the Canadian province of Quebec and the Maritime provinces, lights are often sideways, but each a different shape. Red is a square and usually in pairs at either end of the fixture, yellow is a diamond, and green is a circle. In Texas and many southern and southwestern states, most traffic signals are horizontal in order to ease wind resistance during storms and hurricanes. In Britain, normal traffic lights follow this sequence: red, red and amber, green, amber, pedestrian and cyclist crossing lights. Sounds: in some jurisdictions such as Australia and Ireland, pedestrian lights are associated with a sound device, for the benefit of blind and visually impaired pedestrians. These make a slow beeping sound when the pedestrian lights are red and a continuous buzzing sound when the lights are green. In the Australian territories of New South Wales, Victoria and Western Australia, the sound is produced in the same unit as the push buttons. This system of assistive technology is also widely used at busy intersections in Canadian cities. The United Kingdom, the puffin crossings and their predecessor, the pelican crossing, will make a slow beeping sound to indicate that it is safe to cross the road. The beeping sound is disabled during the night times so as not to disturb any nearby residents. Australia and New Zealand: in Australia and New Zealand, the light sequence is: green man, safe to cross the intersection; flashing red man, continue to cross if already in the intersection, but do not start to cross; red man, do not cross. Some traffic lights in Melbourne had countdown timers for pedestrian crossing lights, usually a countdown from 30 when the red flashing man appeared. This however was a trial and was removed as it resulted in large amounts of jaywalking. Countdown timers have been installed on some pedestrian crossing lights in Auckland, counting down from 15 seconds. Some traffic light control junctions have a light sequence that stops all vehicular traffic at the junction at the same time, and gives pedestrians exclusive access to the intersection so that they can cross in any direction. This is known as a pedestrian scramble in some places. In New Zealand, such pedestrian crossings can be found in the central business district of Auckland, Wellington and Christchurch. European standard. The European approach to a signalised crossing is to use dual or, more rarely, a triple aspect with a blackened out lens of a pictogram pedestrian. For cyclists, the same approach is used, with the lens blackened out for a bicycle frame. It is not uncommon to see lenses with both symbols on them. Most European countries use orange instead of yellow for the middle light. The light sequence is: green, safe to cross; yellow or orange, continue to cross only if unable to stop safely; flashing yellow or orange, cross with caution; red, do not cross. In Germany, the Czech Republic and some other Central European countries, a combination of red and orange lights is used just before the switch back to green. It allows drivers to stop their engines during the red light. The light sequence is as follows: green, safe to cross. Orange, continue to cross only if unable to stop safely. Flashing orange, cross with caution, obey signage. Red, do not cross. Red and orange, do not cross, prepare for green. The light is blackened out with a pedestrian pictogram. Ampere currency NNCHEN. Pedestrian traffic signals have come to be seen as a nostalgic sign for the former German Democratic Republic. British Standard, in the United Kingdom, British Crown dependencies, independent territories, and former possessions like Hong Kong. Green, walking man, cross with caution, pedestrians have the right of way. Motorists turning left or right must yield to pedestrians. Flashing green, walking man, continue to cross if already in the intersection, but do not start to cross. Red or orange, standing man, do not cross. The same system is used also in Switzerland and Macau. China Standard, blue-white, cross with caution. Red-orange, do not cross. North American Standard. In North America, the most common aspects found are text-only lenses or the pictogram of a red or orange hand and a walking person. Increasingly for retrofits of dual aspects and newer installations, the lower aspect formerly used for the walk signal is being replaced with a timer countdown. The raised hand pictogram first appeared in the city of Westmount, Montreal, and was invented by Alexander Heron, having observed a policeman's gloved hand controlling a crossing. The light sequence is green, blue, or white, walking human or walk, cross with caution. Flashing red or orange, stop hand or don't walk, do not start crossing, but continue if already in the middle of the intersection. Red or orange, stop hand or don't walk, do not enter the intersection. The U.S. state of Massachusetts allows an unusual indication variation for pedestrian movement. At signalized intersections without separate pedestrian signal heads, the traffic signals may be programmed to turn red in all directions, followed by a steady display of yellow lights simultaneously with the red indications. During this red plus yellow indication, the intersection is closed to vehicular traffic and pedestrians may cross, usually in whatever direction they choose. Lights for public transport. Traffic lights for public transport often use signals that are distinct from those for private traffic. They can be letters, arrows or bars of white or colored light. In Portland, Oregon, the tram's signals feature an orange horizontal bar and a white vertical bar. Some systems use the letter B for buses, and T for trams. In Russia, dedicated traffic signals for public transport have 4 white lights that form the letter T. If the 3 top lamps are lit, this means stop. If the bottom lamp and some lamps on the top row are lit, this means permission to go in a direction shown. In case of a tram signal, if there are no tram junctions on an intersection, a simpler system of one yellow signal in the form of letter T is used instead. The tram must proceed only when the signal is lit. In North European countries, the tram's signals feature white lights of different forms, S for stop, a euro for caution, and arrows to permit passage in a given direction. The Netherlands use a distinctive network design shown on the top row of the diagram. Bottom row signals are used in Belgium, France and Germany. The signals mean, go straight ahead, go left, go right, go in any direction, stop, unless the emergency brake is needed, and stop. The Metro light rail system in Minneapolis, Minnesota uses a simplified variant of the Belgian-French system in the city's central business district where only the go and stop configurations are used. A third signal equal to yellow is accomplished by flashing the go signal. In Japan, tram signals are under the regular vehicle signal. However, the color of the signal intended for trams is orange. In Hong Kong Island, Hong Kong, a yellow T signal is used for trams, in place of the green signal. Addition to that, at any tramway junction, another set of signals is available to indicate the direction of the tracks. Preemption and priority. Some regions have signals that are interruptible, giving priority to special traffic, usually emergency vehicles such as fire apparatus, ambulances, and police squad cars. Most of the systems operate with small transmitters that send radio waves, infrared signals, or strobe light signals that are received by a sensor on or near the traffic lights. Some systems use audio detection, where a certain type of siren must be used and detected by a receiver on the traffic light structure. Upon activation, the normal traffic light cycle is suspended and replaced by the preemption sequence. The traffic lights to all approaches to the intersection are switched to red with the exception of the light for the vehicle that has triggered the preemption sequence. Sometimes, an additional signal light is placed nearby to indicate to the preempting vehicle that the preempting sequence has been activated and to warn other motorists of the approach of an emergency vehicle. The normal traffic light cycle resumes after the sensor has been passed by the vehicle that triggered the preemption. In lieu of preemptive mechanisms, in most jurisdictions, emergency vehicles are not required to respect traffic lights. However, emergency vehicles must activate their emergency lights, slow down, and proceed cautiously and activate emergency lights to alert oncoming drivers to the preemption when crossing an intersection against the light. Unlike preemption, which immediately interrupts a signal's normal operation to serve the preempting vehicle and is usually reserved for emergency use, priority is a set of strategies intended to reduce delay for specific vehicles, especially mass transit vehicles such as buses. A variety of strategies exist to give priority to transit, but they all generally work by detecting approaching transit vehicles and making small adjustments to the signal timing. These adjustments are designed to either decrease the likelihood that the transit vehicle will arrive during a red interval or decrease the length of the red interval for those vehicles that are stopped. Priority does not guarantee that transit vehicles always get a green light the instant they arrive like preemption does. Turning signals and rules. In some instances, traffic may turn left or right after stopping at a red light, providing they give way to the pedestrians and other vehicles. In some places that generally disallow this, a sign next to the traffic light indicates that it is allowed at a particular intersection. Conversely, jurisdictions that generally allow this might forbid it at a particular intersection with a no turn on red sign, or put a green arrow to indicate specifically when a turn is allowed without having to yield to pedestrians. Some jurisdictions allow turning on red in the opposite direction from a one-way road onto another one-way road. Some of these even allow these turns from a two-way road onto a one-way road. Also differing is whether a red arrow prohibits turns. Some jurisdictions require a no turn on red sign in these cases. A study in the state of Illinois concluded that allowing drivers to proceed straight on red after stopping, at specially posted T intersections where the intersecting road went left only, was dangerous. Proceeding straight on red at T intersections where the intersecting road went left only used to be legal in mainland China, with right-hand traffic provided that such movement would not interfere with other traffic, but when the Road Traffic Safety Law of the People's Republic of China took effect on May 1, 2004, such movement was outlawed. In some other countries, the permission is indicated by a flashing yellow arrow. Another distinction is between intersections that have dedicated signals for turning across the flow of opposing traffic and those that do not. Such signals are called dedicated left turn lights in the United States and Canada. With dedicated left turn signals, a left-pointing arrow turns green when traffic may turn left without opposing traffic and pedestrian conflict, and turns red or disappears otherwise. Such a signal is referred to as a protected signal if it has its own red phase. A permissive signal does not have such a feature. 3 standard versions of the permissive signal exist. One version is a horizontal bar with 5 lights. The green and yellow arrows are located between the standard green and yellow lights. A vertical 5-light bar holds the arrows underneath the standard green light. Some newer LED turn arrows seen in parts of Canada are capable of multicolored animation. Such lights will often display a flashing and animated green or yellow arrow when the dedicated turn is allowed, but then transform into a red arrow on a white background with a red line through it, emphasizing that the turn is no longer allowed. These lights will also often have the words "no turn" displayed, or an explanatory reason why the turn is not allowed, such as train in the case of a rail or light rail crossing. A third type is known as a doghouse, or cluster head a vertical column with the two normal lights is on the right side of the signal, a vertical column with the two arrows is located on the left, and the normal red signal is in the middle above the two columns. Cluster signals in Australia and New Zealand use 6 signals, the sixth being a red arrow that can operate separately from the standard red light. In a fourth type, sometimes seen at intersections in Ontario and Quebec, Canada, there is no dedicated left-turn lamp per se. Instead, the normal green lamp flashes rapidly, indicating permission to go straight as well as make a left turn in front of opposing traffic, which is being held by a steady red lamp. Another interesting practice seen at least in Ontario is that cars wishing to turn left that arrived after the left turn signal ended can do so during the yellow phase, as long as there is enough time to make a safe turn. A flashing yellow arrow, which allows drivers to make left turns after giving way to oncoming traffic, is becoming more widespread in the United States, particularly in Oregon, Michigan, and Las Vegas, Nevada. In the normal sequence, a protected green left-turn arrow will first change to a solid yellow arrow to indicate the end of the protected phase, then to a flashing yellow arrow, which remains flashing until the standard green light changes to yellow and red. These generally take the form of 4 signal sections. On some newer signals, notably in the city of Bend, the green and flashing yellow arrows emanate from the same light section through the use of a dual-color LED array, while the solid yellow arrow is mounted above it. In Las Vegas, the arrow turns flashing yellow from a red light, before turning red again. Generally, a dedicated left-turn signal is illuminated at the beginning of the green phase of the green-yellow-red-green cycle. This is called a leading turn. This allows left-turn traffic, which often consists of just a few cars, to vacate the intersection quickly before giving priority to vehicles traveling straight. This increases the throughput of left-turn traffic while reducing the number of drivers, perhaps frustrated by long waits in heavy traffic for opposing traffic to clear, attempting to make an illegal left turn on red. A dedicated left-turn signal that appears at the end of the green phase is called a lagging turn. If there is no left-turn signal, the law requires one to yield to oncoming traffic and turn when the intersection is clear and it is safe to do so. Nevertheless, it is increasingly common in the U.S. to see drivers who do not yield in the absence of a dedicated signal, cutting off traffic that is the right-of-way and is starting to head across the intersection. In the U.S., many older inner-city and rural areas do not have dedicated left-turn lights, while most newer suburban areas have them. Such lights tend to decrease the overall efficiency of the intersection as it becomes congested, although it makes intersections safer by reducing the risk of head-on collisions and may even speed up through traffic, but if a significant amount of traffic is turning, a dedicated turn signal helps eliminate congestion. Some intersections with permissive turn signals occasionally have what is known as yellow trap, lag trap, or left turn trap. This refers to situations when left-turning drivers are trapped in the intersection with a red light, while opposing traffic still has a green. In British Columbia, the law addresses this problem by giving a left-turning driver already in an intersection the right-of-way to make the turn once the intersection is otherwise clear, regardless of the traffic light state. For example, an intersection has dedicated left-turn signals for traffic traveling north. The southbound traffic gets a red light so northbound traffic can make a left turn, but the straight-through northbound traffic continues to get a green light. A southbound driver who had entered the intersection earlier will now be in a predicament, since they have no idea whether traffic continuing straight for both directions is becoming red, or just their direction. The driver will now have to check the traffic light behind them, which is often impossible from the viewing angle of a driver's seat. This can also happen when emergency vehicles or railroads preempt normal signal operation. In the United States, signs reading oncoming traffic has extended green, or oncoming traffic may have extended green must be posted at intersections where the yellow trap condition exists. Although motorcycles and scooters in most jurisdictions follow the same traffic signal rules for left turns as do cars and trucks, some places, such as Taiwan, have different rules. In these areas, It is not permitted for such small and often hard-to-see vehicles to turn left in front of oncoming traffic on certain high-volume roads when there is no dedicated left turn signal. Instead, in order to make a left turn, the rider moves to the right side of the road, travels through the first half of the intersection on green, then slows down and stops directly in front of the line of cars on the driver's right waiting to travel across the intersection, which are of course being held by a red light. There is often a white box painted on the road in this location to indicate where the riders should group. The rider turns the bike 90 degrees to the left from the original direction of travel and proceeds along with the line of cars when the red light turns green, completing the left turn. This procedure improves safety because the rider never has to cross oncoming traffic, which is particularly important given the much greater likelihood of injury when a cycle is hit by a car or truck. This system is also used at many intersections in the CBD of Melbourne, Australia, where either or both streets carry tramways. This is done so right-turning vehicles do not block the passage of trams. The system is being extended to the suburbs. Lane control. Lane control lights are a specific type of traffic light used to manage traffic on a multi-way road, highway or tollway. Typically, these lights allow or forbid traffic to use one or more of the available lanes by the use of green lights or arrows or by red lights or crosses. In the U.S., lane control lights are often used to control and/or direct the flow of traffic through toll plazas and highway tunnels, such as during unusually heavy traffic flow when more lanes may be required in one direction than in the other direction, or during a hurricane evacuation, when the lane signals for all lanes will show green for one direction to assist in more rapid traffic flow from the evacuation site. Lane control lights are also used at highway weigh stations to direct tractor-trailers and other heavy or oversized vehicles into the proper lanes for weighing, inspection or exit. In the U.S., most notably the southeastern, there often is a continuous flow lane. This lane is protected by a single, constant green arrow pointing down at the lane, permitting the continuous flow of traffic, without regard to the condition of signals for other lanes or cross streets. Continuous lanes are restricted in that vehicles turning from a side street may not cross over the double white line to enter the continuous lane, and no lane changes are permitted to the continuous lane from an adjacent lane or from the continuous lane to an adjacent lane, until the double white line has been passed. Some continuous lanes are protected by a raised curb located between the continuous lane and a normal traffic lane, with white and/or yellow reflective paint or tape, prohibiting turning or adjacent traffic from entering the lane. Continuous flow traffic lanes are found only at T intersections where there is no side street or driveway entrance on the right side of the main thoroughfare. Additionally, no pedestrians are permitted to cross the main thoroughfare at intersections with a continuous flow lane, although crossing at the side street may be permitted. Intersections with continuous flow lanes will be posted with a white regulatory sign approximately 500 feet before the intersection with the phrase, "Right lane continuous traffic," or other, similar, wording. If the arrow is extinguished for any reason, whether by malfunction or design, traffic through the continuous lane will revert to the normal traffic pattern for adjacent lanes, except that turning or moving into or out of the restricted lane is still prohibited. Special provisions. Traffic light failure in most jurisdictions in both drive on the left Australia and some states of the mainly drive on the right Europe must be handled by drivers as a priority to the right intersection, or an all-way stop elsewhere, pending the arrival of a police officer to direct traffic. Some jurisdictions, however, have additional right-of-way signs mounted above, below or next to the traffic lights. These take effect when the lights are no longer active. In the UK and parts of North America, drivers simply treat the junction as being uncontrolled when traffic lights fail, giving way as appropriate, unless a police officer is present. In much of the United States, failed traffic signals must be treated as all-way stop intersections. In Italy as well as some jurisdictions in the US, traffic lights inactive at nighttime emit a yellow-colored flashing signal in directions owing priority while the intersecting streets emit a flashing red light, requiring drivers to stop before proceeding. In Germany, the priority directions will not be illuminated while the intersecting streets will be shown a flashing yellow signal. Dummy lights. In an era when intersections were often controlled by a single traffic signal head, many signals were installed on pedestals in the centers of intersections. Often referred to as dummy lights, these installations often replaced beacons or mushrooms that denoted the centers of intersections and separated opposing traffic, with the infrastructure used for the beacons and mushrooms serving the new stop-and-go type signals. There are a handful of operational dummy lights still in service. 3 are located in New York State: Beacon, Canajoharie and Croton-on-Hudson. After a dummy light was knocked down by a truck in 2010, the city of Coleman, Texas decided to preserve and refurbish its last 2 pedestal-mounted dummy lights as part of its historic district preservation efforts. In 2011, the Arkansas State Historic Preservation Office nominated the state's last remaining pedestal-mounted signal, located in Smackover, to be listed on the National Register of Historic Places. Increases in traffic flows have prompted calls for these types of traffic lights to be removed due to safety concerns, but their historic value has kept these landmarks at their original locations. To serve historic district applications, TECO Safety Systems of Shreveport, Louisiana, still manufactures replacement fixed four-way traffic signals for pedestal and overhead span wire installations. Technology, optics and lighting. Traditionally, incandescent and halogen bulbs were used. Because of the low efficiency of light output and a single point of failure, municipalities are increasingly retrofitting traffic signals with LED arrays that consume less power, have increased light output, last significantly longer, and in the event of an individual LED failure, still operate albeit with a reduced light output. With the use of optics, the light pattern of an LED array can be comparable to the pattern of an incandescent or halogen bulb. The low energy consumption of LED lights can pose a driving risk in some areas during winter. Unlike incandescent and halogen bulbs, which generally get hot enough to melt away any snow that may settle on individual lights, LED displays are using only a fraction of the energy remain too cool for this to happen. Programmable visibility signals. Signals such as the 3M high visibility signal and McCain programmable visibility signal utilize light diffusing optics and a Fresnel lens to create the signal indication. Lit via a powerful 150 WPAR46 sealed beam lamp, the light from the lamp and these programmable visibility signals passes through a set of 2 glass lenses at the back of the signal. The first lens, a frosted glass diffusing lens, diffuses the light into a uniform ball of light around 5 inches in diameter. The light then passes through a nearly identical lens known as an optical limiter, also known as a programming lens, also 5 inches in diameter. Using a special aluminum foil-based adhesive tape, these signals are masked, or programmed via the programming lens so that only certain lanes of traffic will view the indication. At the front of these programmable visibility signals is a 12 inches Fresnel lens, each lens tinted to meet United States Institute of Transportation Engineers chromaticity and luminance standards. The Fresnel lens collimates the light output created by the lamp, and creates a uniform display of light for the lane in which it is intended. These signals were first developed by the 3M company in the late 1960s. And were popular in the late 1970s as traffic density increased. In addition to being positioned and mounted for desired visibility for their respective traffic, some traffic lights are also aimed, louvered, or shaded to minimize misinterpretation from other lanes. For example, a Fresnel lens on an adjacent through-lane signal may be aimed to prevent left-turning traffic from anticipating its own green arrow. One example of the Fresnel lens application common in the USA is the 3M Model 131 traffic signal. Today, McCain Traffic Systems is the only US-based manufacturer producing optically programmable traffic signals similar to the 3M model. IntLight Incorporated manufactures a programmable traffic signal that uses a software-controlled LED array and electronics to steer the light beam toward the desired approach. The signal is programmed unlike the 3M and McCain models. It requires a connection to a laptop or smartphone with the manufacturer's software installed. Connections can be made directly with a direct serial interface kit, or wirelessly with a radio kit over Wi-Fi to the signal. In addition to aiming, Fresnel lenses, and louvers, visors and back panels are also useful in areas where sunlight would diminish the contrast and visibility of a signal face. Typical applications for these signals were skewed intersections, specific multi-lane control, left-turn pocket signals or other areas where complex traffic situations existed. Conventional lighting systems, conventional traffic signal lighting, still common in some areas, utilizes a standard light bulb. Typically, a 67, 69, or 115-watt medium base light bulb provides the illumination. Light then bounces off a mirrored glass or polished aluminium reflector bowl, and out through a polycarbonate plastic or glass signal lens. In some signals, these lenses were cut to include a specific refracting pattern. Krause-Heinz is one notable company for this practice. In the 1930s throughout the 1950s, they utilized a beaded prismatic lens with a smiley pattern embossed into the bottom of each lens. Light design. In the United States, traffic lights are currently designed with lights approximately 12 inches in diameter. Previously the standard had been 8 inches, however those are slowly being phased out in favor of the larger and more visible 12-inch lights. Variations used have also included a hybrid design, which had one or more 12-inch lights along with one or more lights of 8 inches on the same light. For example, these 12-8-8 lights are standard in most jurisdictions in Ontario, Manitoba, and British Columbia. In the United Kingdom, 12-inch lights were implemented only with Mellor design signal heads designed by David Mellor. These were designed for symbolic optics to compensate for the light loss caused by the symbol. With the invention of anti-phantom, highly visible SIRA lenses, lights of 8 inches could be designed to give the same output as plain lenses, so a larger surface area was unnecessary. Consequently, lights of 12 inches are no longer approved for use in the UK, and all lights installed on new installations have to be 200 mm in accordance with TSRGD. Exemptions are made for temporary or replacement signals. Technological advancements. With technologies in developed countries continuing to advance, there is now an increasing move to develop and implement smart traffic lights on the roads. These are basically more intelligent systems that try to communicate with cars to alert drivers of impending light changes and reduce motorists' waiting time considerably. Trials are currently being conducted for the implementation of these advanced traffic lights, but there are still many hurdles to widespread use that need to be addressed. One of which is the fact that not a lot of cars yet have the required systems to communicate intelligently with these lights. Control and coordination. The normal function of traffic lights requires sophisticated control and coordination to ensure that traffic moves as smoothly and safely as possible and that pedestrians are protected when they cross the roads. Mounting. There are significant differences from place to place in how traffic lights are mounted or positioned so that they are visible to drivers. Depending upon the location, traffic lights may be mounted on poles situated on street corners, hung from horizontal poles or wires strung over the roadway, or installed within large horizontal gantries that extend out from the corner and over the right-of-way. In the last case, such poles or gantries often have a letter sign with the name of the cross street. In some locations, lights are mounted with their multiple faces arranged horizontally, often with supplemental vertical signals on the side, while others locations use vertical signals almost exclusively. Horizontal signals have consistent orientation, like their vertical counterparts. Often, supplemental curb pedestal mounts, intended to support a signal for a different approach road, are used when primary signals are partially obscured due to structures such as overpasses, approaches around a building that obscures the primary signal mountings, and unusual approach geometry. In Florida, horizontal signals mounted on poles, known as mast arms, are in wide use due to their lower wind profile, important for minimizing hurricane damage. In areas where wind load is not as much of a concern as ice load, such as Illinois or Minnesota, the lights are mounted vertically to reduce the accumulation of ice or snow over the surface of the signal heads. Traffic signals in most areas of Europe are located at the stop line on the same side of the intersection as the approaching traffic and are often mounted overhead as well as on side of the road. At particularly busy junctions for freight, Higher lights may be mounted specifically for trucks. The stop line alignment is done to prevent vehicles blocking any crosswalk and allow for better pedestrian traffic flow. There may also be a special area a few meters in advance of the stop line where cyclists may legally wait but not motor vehicles. This advanced stop line is often painted with a different road surface with greater friction and a high color, both for the benefit of cyclists and for other vehicles. The traffic lights are mounted so that cyclists can still see them. In Spain, the mounted traffic lights on the far side of the intersection is meant for the traffic that exits the intersection in that particular direction. This is often done due to the pedestrian crossings, so that traffic have to wait if they get a red light. These intersections also comes with a stop line in the exit area of the intersection. In North America, there is often a pole-mounted signal on the same side of the intersection, but additional pole-mounted and overhead signals are usually mounted on the far side of the intersection for better visibility. Most traffic lights are mounted that way in the western United States and Canada. In some areas of the United States, signals facing in up to 4 directions are hung directly over the intersection on a wire strung diagonally over the intersection, or the signal faces traffic in one direction, still hung by wires. This is common in the southern and eastern United States. In other countries like Australia, New Zealand, UK, the mounting of traffic lights are always located at the stop line before the intersection and also after the intersection. Some busy intersections have an overhead traffic light for heavy vehicles and vehicles further away. Implementation: according to transportation engineers, traffic lights can have both positive and negative effects on traffic safety and traffic flow. The separation of conflicting streams of traffic in time can reduce the chances of right-angle collisions. But also the frequency of rear-end crashes can be increased by the installation of traffic lights, and they can adversely affect the safety of bicycle and pedestrian traffic. They can increase the traffic capacity at intersections, but can also result in excessive traffic delay. Hans Monderman, the innovative Dutch traffic engineer, and pioneer of shared space schemes, was skeptical of their role, and is quoted as having said of them, "We only want traffic lights where they are useful and I haven't found anywhere where they are useful yet." Small vehicle safety: in some instances the stoplight traffic detector will not change the light for small vehicles such as motorcycles, scooters and particularly bicycles, because the induction loop sensor fails to detect the small vehicle. A vehicle with sufficient mass of metal such as steel interacts with the sensor's magnetic field, causing the light to change at the appropriate time. Motorcycles and scooters have much less mass than cars, resulting in a failure to trigger the sensor, while bicycles may not even be constructed with metal. This situation most often occurs at the times of day when other traffic is sparse, as well as when the small vehicle is coming from a direction that does not have a high volume of traffic. Not all sensor traffic lights have this problem. There are some that can pick up these vehicles without problems and most are capable of doing so. However, through road construction and other processes, they are not properly adjusted or calibrated for the small vehicles. Magnetic field sensors detect vehicles passing over them and not necessarily stationary vehicles. Actuated traffic lights: some states in the United States have passed laws which give motorcyclists an affirmative defense to proceed through a red light with caution after stopping when the device which causes the light to change from red to green does not activate. A partial listing of these state statutes include Wisconsin 346.37, 1, c. 4, Illinois Sec 11-306, c. 3.5, Minnesota 169.06 SUBD 9, South Carolina SC Code 56-5-970, North Carolina, Idaho, Arkansas, and Tennessee. Additional state laws regarding actuated traffic lights can be found at the American Motorcycle Association website, including this quick reference guide. Traffic signal warrants: traffic signals have strengths and weaknesses that must be considered when deciding whether to install them. Signaled intersections can reduce delay for side road traffic and reduce the occurrence of collisions by turning traffic and cross traffic. But they may also cause delay for traffic on the main road, and often increase rear-end collisions by up to 50%. Since right-angled and turn-against traffic collisions are more likely to result in injuries, this is often an acceptable trade-off. United States MUTCD criteria have been developed to help ensure that new signals are installed only where they will do more good than harm. In the United States, these criteria are called warrants, and are found in the Manual on Uniform Traffic Control Devices, the federal regulation covering the use of signs, pavement markings, traffic signals, and similar devices. In the US MUTCD, there are 9 warrants for traffic signals. 8-hour vehicular volume. Traffic volume must exceed prescribed minima for 8 hours of an average day. 4-hour vehicular volume. Traffic volume must exceed prescribed minima for 4 hours of an average day. Peak hour volume or delay. This is applied only in unusual cases, such as office parks, industrial complexes, and park and ride lots that attract or discharge large numbers of vehicles in a short time, and, for a minimum of 1 hour of an average day. The side road traffic suffers undue delays when entering or crossing the major street. Pedestrian volume. If the traffic volume on a major street is so heavy that pedestrians experience excessive delays in attempting to cross it. School crossing. If the traffic density at school crossing times exceeds 1 per minute, which is considered to provide too few gaps in the traffic for children to safely cross the street. Coordinated signal system. For places where adjacent traffic control signals do not keep traffic grouped together efficiently. Crash experience. The volumes in the 8 and 4-hour warrants may be reduced if 5 or more right-angle and cross-traffic turn collisions have happened at the intersection in a 12-month period. Roadway network. Installing a traffic control signal at some intersections might be justified to encourage concentration and organization of traffic flow on a roadway network. Intersection near a grade crossing. A traffic control signal is often justified at an intersection near a railroad crossing, in order to provide a preemption sequence to allow traffic queued up on the tracks an opportunity to clear the tracks before the train arrives. An intersection is usually required to meet one or more of these warrants before a signal is installed. However, meeting one or more warrants does not require the installation of a traffic signal, it only suggests that they may be suitable. It could be that a roundabout would work better. There may be other unconsidered conditions that lead traffic engineers to conclude that a signal is undesirable. For example, it may be decided not to install a signal at an intersection if traffic stopped by it will back up and block another, more heavily trafficked intersection. Also, if a signal meets only the peak hour warrant, the advantages during that time may not outweigh the disadvantages during the rest of the day. Between 1979 and 1988, the city of Philadelphia, Pennsylvania, removed 199 signals that did not meet any of the warrants. On average, the intersections had 24% fewer crashes after the unwarranted signals were removed. Legal implications. In virtually all jurisdictions in which they are used, it is an offense for motorists to disregard the instructions of traffic lights. Exceptionally, it is not an offense for pedestrians to cross against a red light in the United Kingdom, where pedestrian lights officially give advice, rather than an instruction, although UK pedestrians do commit an offence if they cross a road against the signals of a police officer controlling traffic. Perhaps the most obvious common traffic light-related offence is failing to stop for a red light. Enforcement of traffic lights varies from jurisdiction to jurisdiction. Some places are extremely strict, while other locales are known for traffic lights being routinely ignored by motorists, with no serious attempts by law enforcement to alter the situation. Jurisdictions differ somewhat on how to deal with red light running attempts by motorists to race to an intersection while facing a yellow light, in an attempt to beat the red. In some locales, as long as the light is yellow when the motorist enters the intersection, no offense has been committed. In others, if the light turns red at any time before a motorist clears the intersection, then an offense occurs. In Oregon and other places, a stricter standard applies. Running a yellow light is an offense, unless the motorist is unable to stop safely. This standard has been criticized as ambiguous and difficult to enforce. Red light cameras in New South Wales, Australia, are activated only if a motorist enters an intersection 0.3 seconds after the light has turned red. In some jurisdictions, there are ordinances or bylaws against gridlocking. A motorist entering an intersection but unable to proceed and who gets stranded in the intersection, and who remains after the light turns red may be cited. The definition of the intersection area is that square where the two streets overlap marked by the inner lines of each crosswalk. This gives the meaning to the anti-gridlock slogan "Don't block the box." This is sometimes used as a justification for making a turn across the opposing travel lanes on a red light at a busy intersection, by pulling partway into the intersection at a green light waiting to perform the turn, and, if oncoming traffic is not abated before the light changes to red, proceeding to turn once the light has turned red and opposing traffic has stopped. This means that at busy junctions without a protected green arrow for turning traffic, one turns after the light turns red. This maneuver is commonly referred to as occupying the intersection, or being legally allowed to complete one's turn. In some jurisdictions, including most American states, a vehicle already in the intersection when the light turns red legally has the right of way, and vehicles who have green must yield to the vehicle in the intersection. In Sackville, New Brunswick, it is customary for through traffic to voluntarily yield to the first oncoming left-turning vehicle to allow it to perform a Pittsburgh left. This is similar to a hook turn performed in Melbourne, Australia, which is legal at signed intersections. Enforcement of traffic lights is done in one of several ways, by police officers observing traffic, and issuing citations to motorists who violate the signal. As a result of an accident investigation, if it is determined that one or more motorists ran the red light even if the incident was not observed by a police officer, with red light cameras. In some countries, red light cameras are used. An automated camera is connected to the triggering mechanism for the corresponding traffic light, which is targeted to photograph a vehicle and driver crossing against the light. Either the driver or the vehicle's owner are fined for the violation. In some jurisdictions, including the United States and Italy, private companies have been contracted to operate traffic-related cameras and receive a portion of the resulting revenues. In some cases, red light cameras have been abused by local governments, where vehicle operators have been fined as a result of traffic systems that have been improperly modified. Light timing length. The length of yellow lights can differ. For example, in many places the length of a yellow light is usually 4 or 5 seconds, but elsewhere it may be as little as 3, considerably reducing the time for reaction. It is typical for these times to vary according to the set speed limit, with longer times for higher limits. In the U.S. state of Georgia, a yellow light must be lit 1 second for every 10 miles per hour of posted speed limit. For intersections with red light cameras, 1 extra second must be added. In Colorado Springs, Colorado, yellow lights at numerous intersections have been noted with durations of approximately 2 seconds. In the United States, there is a recommended federal safety minimum of 3 seconds for yellow lights. The time from when a red light is displayed and when a cross street is given a green light is usually based on the physical size of the intersection. This intervening period is called the all-red time. A typical all-red time is 2 seconds to allow cars to clear the intersection. In a wider intersection, such as a 4-lane road or highway intersection, the all-red time may be as much as 5 seconds, allowing drivers who could not or would not stop at the yellow light enough time to clear the intersection without causing a collision. 2 exceptions are in New Westminster, British Columbia, Canada, and Winnipeg, Manitoba, Canada, where there is no all-red time. The change is instantaneous, due to the nature of the older relay-operated signals. It is also the case in Montreal, Quebec, Canada. In other contexts, the symbolism of a traffic light are frequently found in many other contexts. Since they are often used as single spots of color without the context of vertical position, they are typically not comprehensible to up to 1 in 10 males who are colorblind. Traffic lights have also been used in pieces of artwork, particularly the traffic light tree in London, UK. Racing, automobile racing circuits can also use standard traffic signals to indicate to racing car drivers the status of racing. On an oval track, 4 sets may be used, 2 facing a straightaway and 2 facing the middle of the 180-degree turn between straightaway. Green would indicate racing is underway, while yellow would indicate a slow or while following a pace car. Red would indicate a stop, probably for emergency reasons. Scuderia Ferrari, a Formula One racing team, formerly used a traffic light system during their pit stops to signal to their drivers to when to leave the pits. The red light was on when the tires were being changed and fuel was being added, yellow was on when the tires were changed, and green was on when all work was completed. The system is completely automatic. However, the system was withdrawn after the 2008 Singapore Grand Prix, due to the fact that it heavily delayed Felipe Massa during the race, when he was in the lead. Usually, the system was automatic, but heavy traffic in the pit lane forced the team to operate it manually. A mechanic accidentally pressed the green light button when the fuel hose was still attached to the car, causing Massa to drive off, towing the fuel hose along. Additionally, Massa drove into the path of Adrian Sutil, earning him a penalty. He finally stopped at the end of the pit lane, forcing Ferrari's mechanics to sprint down the whole of the pit lane to remove the hose. As a result of this, and the penalty he also incurred, Massa finished 13th. Ferrari decided to use a traditional lollipop for the remainder of the 2008 season. Another type of traffic light that is used in racing is the Christmas tree, which is used in drag racing. The Christmas tree has 6 lights, a blue staging light, 3 amber lights, a green light and a red light. The blue staging light is divided into 2 parts, pre-stage and stage. Sometimes, there are 2 sets of bulbs on top of each other to represent them. Once a driver is staged at the starting line, then the starter will activate the light to commence racing, which can be done in 2 ways. If a pro tree is used, then the 3 amber lights will flash at the same time. For the sportsman tree, the amber light will flash from top to bottom. When the green light comes up, the race officially begins, but if a driver crosses the line before that happens, then a red light will come up and that will be a foul. As a rating mechanism, the colors red, yellow and green are often used as a simple-to-understand rating system for products and processes. It may be extended by analogy to provide a greater range of intermediate colors, with red and green at the extremes. Gallery. See also, Ampere currency NNCHEN, induction loop, level crossing, list of variations in traffic light signaling and operation for a more complete description of unusual traffic signal indications. Pedestrian crossing, ramp meter, traffic light signaling and operation, traffic light control and coordination, traffic optimization, yellow trap, smart traffic light, slow children at play, notes. References. Citations. External links, FHWA Arterial Management website, latest information on traffic signal operations, traffic lights by Ed Pegg, Jr., Wolfram Demonstrations Project, demonstrates that there are 7 distinct light cycles that will prevent collisions. Animations of various U.S. signal phasings, microcontroller-based traffic light controller. SCATSA Euro-Sydney Coordinated Adaptive Traffic System, in sync, the #1 self-optimizing traffic signal system. Pioneer in artificial intelligence and robotics for traffic signal optimization, safety evaluation of converting traffic signals from incandescent to light-emitting diodes, summary report Federal Highway Administration, safety evaluation of discontinuing late-night flash operations at signalized intersections. Summary Report Federal Highway Administration, Traffic Signals, 1922, digitized NYPD photograph from the Lloyd Seeley Library Digital Collections.